We have the guided notes for functions. This is going to be a lot of review, just so we can have a good idea of what functions are and what domain and range really mean. So here, let's get started. A what is a set of ordered pairs. A relation is a set of ordered pairs. Now, mind you, I'm not really great with this pen yet, so we're going to work through that together. The domain of a relation is the set of all first coordinates from the ordered pairs, and the range is the set of all second coordinates from the ordered pairs. Now here it's asking us to state the domain and range of the relation. Now the domain is the first coordinate and the range is the second coordinate. Now mind you, it's a set of those. So we're going to state the domain in set notation. So we're going to say it's 4, -7, 2, and 5. Those are all the first coordinates from each ordered pair, and the range all the second coordinates from each ordered pair. So we're going to just list off all the second coordinates. We have -2, 6, -3, and 7. A relation can be graphed on a coordinate plane. That's a big word to write in that little space for me, so I'm going to write coordinate plane. Oh, that looks like 2 words. Put 2 words there. Plane. The horizontal and vertical axes of a coordinate plane meet at the origin and divide the plane into 4 quadrants. QUA quadrants. Any what in the coordinate plane can be written in the form x, y. Any ordered pair. And that goes right here. Now here, looking at a coordinate plane, we have labeled the quadrants of the coordinate plane. Well, starting with the positive, we're going to label this as 1. And we're going to go counterclockwise and using Roman numerals. 2, 3, and 4. Quadrant 1, 2, 3, and 4. Now mind you, we have axes here. So if we have a point, let's say 0, 3. Let's look at that point there, 0, 3. Now, that's not necessarily on. That's not necessarily in a quadrant. It's on an axis. So that we would say it is not a part of a quadrant. Alright, and locate the coordinates. Name the quadrant in which P, some point P, which is 3, -9, is located. Well, we go 3 in the x direction, 1, 2, 3 in the x, and -9 in the y. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be somewhere down here. Is that point P. And that point is definitely in the 4th quadrant. So we put 4 here. Again, stating our quadrants using Roman numerals. A relation can also be represented, by a table or mapping. A mapping illustrates how each element of the domain is paired with an element in the range. So just like a coordinate pair shows us how the elements of the domain are with the range, a mapping does the same thing. Boy, I did a really bad job with that. A relation can also be represented by a table or a mapping. A mapping illustrates how each element of the domain is paired with an element in the range. Now, that would look like the little red lines going from domain to range. We're going to look at those in a minute. Now, a function is a relation in which each element of the domain is paired with exactly one element of the range. Now, one way I like to think about functions is that you can't have 2 outputs for 1 input. Right? So, 1 input cannot have 2 outputs. And that seems to make a little bit of sense to me. Especially if we think about a function as something that as a set of inputs and outputs. Well, in the real world, we can put something into a function, and it'll spit out something else. And in general, I like to think about that as a pizza oven, right? Where here I can put a pizza, an uncooked pizza with toppings and everything here, and it'll go all the way through, and it'll come out as a cooked pizza. Now, never in the history of man has somebody put one uncooked pizza in a pizza oven, and boom, 2 pizzas showed up at the end. Now, if we had figured that out, Papa John's will pay you $1 million for that thing. That'd be a great idea. So if you figure it out, you let me know first, okay? Here it's asking us to identify the domain and range, and then we're going to determine whether each relation is a function. Alright, so here we're going to identify the domain and range, and we've already done that with ordered pairs, so let's go ahead and let's identify the domain. It's the first coordinate in each ordered pair. So here we have -6, 5, 9, and -2. And looking at the range, we have 0, 5, -2, and -9. So 0, 5, -2, and -9. Now here we have a table of values, right, where it gives us the x values, which is our domain. So our domain is pretty well spelled out for us: 0, 4, and 8. And the range is given as 4, 7, and 4. Okay, now let's determine. Sorry for jumping back. Let's determine now if A is a function. Well, what I'm looking for to quickly see is, do I have more than one -6? Or more than one 5? Or more than one 9? No. And each one of these is set up to be paired with exactly 1 in the range. So this is indeed, yes, this is a function. And we go here to part B. The same thing. Each number in the domain has exactly 1 friend that it's paired up with in the range. So this is as well a function. Alright, we got 2 more examples we want to try here. For C, let's state the domain. The domain, again, being our x values. The domain, we have -2, 0, 4, and 6. And the range, we have -6, -2, 3, and 5. Now the mapping here, now this is a mapping. This is a mapping. And this mapping shows us that -2 is associated with -2. 0 is associated with 3. So as we go through this, we can see that each one of these is paired up with somebody else on the y side. Each x value has a y value. However, this 6 has 2 y values, right? If I put a 6 into this pizza oven, I'm going to get 2 pizzas out, and we know for sure that that can't happen. So this is a big, astounding no. No, this is not a function. And now here we're looking at a coordinate system, or we have 4 points on this coordinate system. So I'm going to take a look at the domain to start with. Again, the domain is our x values. So starting here at the origin, 1 to the left, I have a -1, 0, 1, and 1, 2, 3, 4. And here now we're going to talk about our range. The range is the y values. So I'm going to look on the y-axis here, and I'm going to see, well, starting from the bottom to the top, I'm going to go smallest to largest. I see down here I have a -3. Let me get my pen set here. I have -3, -1, 0, and 2. Right? Because the y value here is -3. My y value here, my y value here is -1. My y value here is 0, and my y value here is 2. So these would be the domain and range for this coordinate pairs. Now, the question is it a function? And absolutely yes, because each dot here, each x value, that's shown has exactly one y value. So yes, this is a function.